of organic compounds. We'll be looking at the IUPAC systematic nomenclature for organic compounds. IUPAC means International Union of Pure and Applied Chemistry, and they've come up with a set of rules that indicates how each organic compound should be named. The name of an organic compound can be divided into three. The first is the root, which is the longest continuous carbon-carbon chain. Longest continuous carbon-carbon chain. Then the next is the prefix or prefixes, which has to do with the substituents. And when I mean substituents, I mean those attachments that substitute hydrogen on the main chain. Whatever is replacing hydrogen on the main chain is a substituent or is an attachment, and these ones make up the prefixes. Then the suffix, which is, of course, this has to do with the main functional group. The main functional group in the compound, and the suffix, of course, comes at the end of the name, just after the root. Now I want us to pay close attention to the root part of the name and the suffix part of the name. Let's start with the root. Now the root has to do, like I said earlier, with the number of carbon atoms in the main chain. And the main chain, I said, is the longest continuous chain. So of course, there are terms that are used to indicate the number of carbons. One means meth. One carbon in the main chain means meth. When you have two carbons, it is eth. 3 carbons, prop. 4 carbons, but. 5 carbons, pent. 6 carbons, hex. 7 carbons, hept. 8 carbons, oct. 9 carbons, non. 10 carbons, dec. So that's the root part of the name. Then if you look at the suffix, like I said, has to do with the functional group. If you look at the table of the homologous series we gave you, you see that the ending of the name of the homologous series will give you an idea of the suffix. The suffix, for example, the functional group in alkenes is the double bond, and it is the double bond that makes the name of alkenes to end with ene. So there is ethene, and when you hear ethene, it means that the eth part means it has 2 carbons, and the ene part means it has a double bond. Then if you hear something like propanol means from the propan or prop, you know that it has 3 carbons. Then from the nol or all part of the name, you know that it is an alkanol. It is an alkanol, and it has, of course, the OH functional group. So that is for the suffix. Now let's also look at the substituents. The substituents, like I said earlier, are the attachments that substitute hydrogen on the main chain. These substituents can be halogen, they can be alkyl group. Now what's an alkyl group? An alkyl group is simply an alkane that is 1 hydrogen short. An alkane that is 1 hydrogen short. For example, we have the methyl, which is CH3 as against CH4 for the methane. So methane is CH4, methyl is CH3. Okay, then we have the ethyl, then we have the propyl, as the case may be. So they are just 1 hydrogen short of the corresponding alkane. So we can have fluorine as a substituent. It will be called fluoro, chlorine, chloro, bromine, bromo, iodo, and so on and so forth. So let's look at the naming proper. Step 1 in naming is to identify the longest continuous carbon atom chain. The longest continuous carbon chain. This is the parent chain. That is what we call the root. That is what I referred to the root initially. So it is the parent chain, the main chain if you prefer, so you must identify it first. So now try to identify the longest continuous carbon chain on this carbon and tell me how many carbon atoms are on the main chain. If you got 6, then you are right. If you didn't get 6, you may need to look again and read through the rule number 1. Rule number 2. You will number the carbon atoms on a chain, on the main chain. And your numbering will be in such a way that the least possible number is given to the substituent. What I mean is, there are 2 ends of a chain and there are 2 possible directions for numbering of carbon atoms. Only one of these 2 is correct. You have to check the one that will give your substituent the lowest possible number. That is the correct direction for numbering. Now, if you have a functional group and a substituent, you must number the carbon atoms with respect to the functional group, not the substituent now. It has to be with respect to the functional group. Rule number 3, you will name each substituent with its position. Name each substituent with its position. Its position is the number of the carbon atom it is attached to. For example, this is 2-methyl propane. 2-methyl propane. The 2 is the position of methyl on the propane main chain. Rule number 4, if you have more than one of the same type of substituent, you may use the prefixes di, tri, tetra, to indicate the number of substituents. If you have 2 substituents, you can use di. For example, this is 1,2-dichloroethane. 1,2-dichloroethane. And this is 2,2-dimethyl-propane. 2,2-dimethyl-propane. Then we also have 2,2,4-trimethylpentane. 2,2,4-trimethylpentane. Rule number 5. If you have different types of substituents, you name the substituents in alphabetical order. There are some examples you may look at, take notes, and copy them down. Rule